Why are structures sensitive to imperfections during buckling? Imagine pushing on a tall, thin column and feeling it wobble just a little. That tiny wobble could be the start of a big problem. Structures are very sensitive to small imperfections when it comes to buckling. This is because even tiny deviations from perfect shape can cause the structure to fail at much lower loads than expected. Buckling is a sudden change in shape that happens when a structure can no longer hold itself up under compression. In a perfect world, calculations tell us exactly when this will happen. But real structures are never perfect. They have tiny dents, uneven surfaces, residual stresses from manufacturing, or slight material flaws. These imperfections act like weak spots or stress concentrators. When the load reaches a certain point, these weak spots become the starting point for buckling. The reason this sensitivity is so high is because buckling is a nonlinear instability. That means small changes can lead to big effects. Once an imperfection causes a tiny deformation, it can quickly grow and cause the entire structure to buckle. This is why a small imperfection can lead to failure at loads for below the theoretical buckling load. It's also why buckling modes can localize in specific areas rather than spreading evenly. This localization makes predicting failure difficult because even tiny differences in shape or material properties can cause different buckling responses. Certain shapes are more sensitive than others. Thin-walled cylinders, for example, are very prone to buckling from small imperfections. These structures can buckle at loads much lower than their ideal calculations suggest. Engineers often use safety factors or knockdown factors to account for this. These are reductions applied to the theoretical buckling load to ensure safety. The sensitivity to imperfections is a key reason why understanding buckling is so important in designing bridges, aircraft, pressure vessels, and other structures. If imperfections are ignored, the structure might look safe on paper but fail unexpectedly in real life. In essence, structures are sensitive to imperfections during buckling because tiny deviations can trigger unstable deformation modes. These modes cause the load-carrying capacity to drop sharply, making it vital for engineers to consider imperfections during design. This helps prevent sudden, catastrophic failures and keeps structures safe and reliable.